Welcome to today's lesson. We're going to be talking about inductors and DC electricity today. To begin with, we're going to start off with some definitions. So DC. DC is better known as direct current. It's an electrical current that flows in one direction. Inductors are a component in an electrical circuit that stores energy in its magnetic field. So how exactly does this work? To explain how an inductor works, we're going to use this diagram here. We've got a battery, a resistor, and an inductor. For the sake of this diagram, though, we're going to imagine that the inductor here is a water wheel with these blades. So, battery is going to produce current, and current is always going to want to flow through the path of least resistance. And at this current point in time, the resistor is going to be that path. So, current will flow out of the battery and around the resistor, following the path of least resistance. But at the same time, current will also flow to the inductor, though it'll be a smaller rate. Eventually, the current will create enough flow through the inductor to get the wheels to begin to move. Once the wheels begin spinning faster and faster, it will reach its maximum speed. Once it's at its max speed, then there will be very little resistance and the current will want to flow through and making this path the path of least resistance. Once the battery is turned off, due to inertia, the inductor will keep spinning, and so therefore it will act as a pump to pump the current through the circuit. The battery can then be turned off and on, and the water wheel or the inductor will continue the flow of the circuit for a short duration. Now we're going to look at how an inductor behaves in a real life circuit. So here I've got a circuit drawn up with a battery, an inductor, and a lamp, or any resistance load really. So for an inductor to work, first of all, it has to be in parallel with its resistance load. The battery is going to produce current, which is going to flow around the circuit. Current is going to want to take the path of least resistance, which at this current point in time is the lamp or the resistance load. But once flow is created in the inductor, current will flow through there, causing the lamp to turn off. Once circuit switch is flicked and battery is no longer in play, then the inductor will act as a pump and flow current through the lamp. The electricity causes inductor to move a magnetic field, which means it can store the energy. When power is cut, magnetic field will slowly collapse, and so magnetic field will be converted into electricity. This pushes electrons along. So where do we use inductors? We can use them in boost converters to create the DC output voltage. We can use them to choke AC supply and allow only DC to pass. We can use them to filter and separate different frequencies. And more commonly, we can also use them for transformers, motors, and relays.